Okay, so this video is going to show you how to graph and write the characteristics of cubic functions. Cubic functions mean the exponent is 3, or the largest, the degree is 3, which means the largest exponent is 3. So the parent function is y equal x to the third power. Alright, so I'm going to pick some x values, and you'll memorize these from practice. First number I'm going to pick is 0. 0 to the third power just means 0 times 0 times 0, which is still 0. So my first coordinate I'm going to have go right to the origin at 0, 0. Alright, my next value I'm going to pick is I'm going to pick 1. Positive 1. 1 to the third power means 1 times 1 times 1, which is 1. So my next coordinate is going to be 1, because I substitute 1, and also comma 1, because when I substitute 1 I also got 1. So my next coordinate is 1, 1. Okay, now I'm going to pick negative 1. Okay, and when you substitute negative numbers, I think it's a great habit of putting your negative numbers in parentheses. It'll still work correctly if you put a negative 1 to the third power in your calculator, because the exponent is odd. You'll still get a negative 1 like you should, but you kind of got it accidentally if you do that, not really knowing maybe not knowing what you're really doing. Which we want you to know what you're doing. Put your negative 1 in parentheses. That means when you have a third power, it's negative 1 times negative 1 times negative 1. The first two negative 1s multiply to make a positive 1. And when you multiply that by a negative 1, you get a final answer of negative 1. So when you substitute negative 1, you get an answer also negative 1. Okay, so this time left 1 down 1. Okay, I'm going to pick two more numbers. The larger the exponent, the fewer x numbers I can pick, because they get so big it won't fit on the grid I have. So I'm going to pick x equal 2. 2 to the third power means 2 times 2 times 2, which is 8. It's not 6, it's 8. So I'm going to put a point at 2 and up here at 8. Alright, last number I'm going to pick is a negative 2. Okay, negative 2 to the third power means a negative 2 times another negative 2 times another negative 2. The first two negative 2's multiply to make a positive 4. And a 4 times a negative 2, that's a negative 8. So when I substitute negative 2, I get a negative 8. So negative 2, negative 8. Alright, ready to draw the curve. Okay, and cubics are called S-curves because they kind of go back and forth like that. Kind of like a snake maybe. Alright, so what are the characteristics? Okay, interval of increase. So off here. Alright, interval of increase, I start use my imagination to start as far to the left as possible. Now when people look at this, say, well, you just picked the point furthest down. Well, that happens to be true too, but when people look at this graph, say, oh, it's going down, 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 but as it's going down, it's ever so slowly creeping over to the left. Okay, so just imagine when you do an interval of increase, how far left is now. That at that point, x is negative 2. So there's negative 2 on the x-axis. But if I had enough room and drew my curve longer, I would eventually could put my little person here at x equal negative 3, right there. And if I kept going, I could draw it at negative 4. Interval of increase, you really have to do imagination. So interval of increase starts at negative infinity, and as you go to the right, he's always increasing. No matter, at x equals 0, the graph's increasing. X equals 1, the graph is increasing. X equals 2, the graph is increasing. Okay? It's always increasing. Which means there's no place as I go left to right it's decreasing. It doesn't have any. Now I look up, I realize, okay, I skipped accidentally domain and range. Alright, let's go back and put in domain and range. I substitute x equals 0. I substitute a positive number x equal 1. I substitute -1, positive 2, -2. I can pick any number and get an answer. So again, it seems like we're always getting all real numbers, and so far we have. Just remember, at some point when we do these kind of functions, 1 over x, rational function, that does not have all real number domain. Okay, square root of x does not have all real number domain. The log functions do not have all real numbers. Even the tangent and the cotangent do not have all real number domain. So there are some that we're not going to have all real numbers. Okay? Alright? So you can also write interval notation. The same thing. The range. What do the answers look like? Okay, well I have an answer here at -8. I have an answer I got at -1. I got an answer at 0. I got an answer at +1. I got an answer of +8. And actually, if I put any other points on this blue curve and go over the y-axis, I could have got an answer of 7. Or I could have got an answer of 6 if I would have picked x strategically. I can get any answer I want. All real numbers. Okay. X-intercept. Where does that blue curve cross the x-axis? Right here at x equals 0. Where does it cross the y-axis? Also at y equals 0. It's still 0, but it means different things. What's the right end? So as we go to the right, at x equals 0, the graph's increasing. At x equal 1, the graph's increasing. Going up at x equal 2, the graph's increasing. As our x values get larger, our y values get larger. Alright, turn your little guy around, use your imagination, make him go left. As I go to -1, my graph is going down. At x equal, when I'm going left, at x equal -2, my graph is going down. Okay. Alright, next function. Next cubic function. This time -x cubed. Okay? It's so useful if you know the basic function. We did +x cubed and know how to change it. Okay? So I'm going to graph y equal +x cubed first. Okay? And you know, with practice you won't have to graph this. You just go ahead and change it. 0, 0, 1, 1, 2, 8. -1, -1, -2, 8. That's y equal +x cubed. Now what does that negative in front do? Okay, just like any function, these always do the same thing, no matter what type of function, quadratic, cubic, square root, trig functions, logarithms. That negative reflects it across the x-axis. So what do? Alright, first of all, so I take my point at 0, 0. I can't reflect that across the x-axis because it's on the x-axis. So I'm going to change that red point to blue. Alright, this point right here at 1, 1, that's 1 above the x-axis. I'm just going to make it go 1 below. Same x value, but just make it 1 below. Okay? This next point at 2, 8, instead of 8 above that, 8 blocks above the x-axis, I'm going to put it way down 8 blocks below. Alright, so I just reflected the right side of that of y equal +x cubed. I have to do the left side, the negative ones. Okay, so here's a point at -1, -1. I just move it above, 1 block above. Like the red dot is 1 below, I just put my blue dot 1 above. My last point is 8 blocks below, I put it 8 blocks above. So my answer is really these blue curves. That's the negative x cubed. So I'm going to erase the red ones because the blue one is really the answer. Alright, what's the domain? Okay, I can substitute anything. Alright, what's the range? I can get any answer I want. Interval of increase is going to change. So I find the left point as far back as I can. I think about getting from that point moving to the right. Well, at x equal -2 to x equal -1, it's going downhill. Okay, from x equal -1 to x equals 0 is going downhill some more. At x equals 0 to x equal 1, going downhill. At from x equal 1 to x equal 2, going downhill. Everywhere is going downhill. So this function is always decreasing. It's never going to go up. None. Doesn't have an interval of increase. Alright, what's the x-intercept? Just like before, just like on y equal positive x cubed. There's your x-intercept 0. What's your y-intercept? Here's your y-axis, the vertical one, at y equals 0. What's the right-hand behavior? Okay, so as we go to the right, it's sweeping down. Okay, so as x approaches positive infinity, y is sweeping down negative infinity. What's happening when you go left? Okay, it's sweeping up like this. Do that different color here, purple. Okay, it's sweeping up. So as x approaches negative infinity, y this time is going up. Okay, just a couple more of these. Y equals x cubed minus 1. Okay, so what's this subtract 1 behind the function mean? Just like any other function. That means you're going to shift the parent function down 1. Okay, so again, here's my parent function. Trust me, you can do this as quickly as I'm doing it right now with some practice. That's the parent function. So if I shift it down 1, okay, make these blue dots. I'm moving this dot down 1 to 7. This point down 1 to the x-axis. The one at the origin down 1. This next red point down 1. This next down here at -8, go it down to -9. So the blue function is the one you want. Alright, so let me erase the red ones. They're so close to each other, it's difficult to really erase it. Best you can. Let's see. And again, you don't have to actually graph the red ones every time. It really shows that you know it if you don't have to graph it all the time. You just go ahead and graph the one you need. Okay, so what's the domain? Every number you can imagine. Range. Alright. We get answers of -9, -2, -1, 0, and 7. And there's all the values below -9, all the values above 7, and every number in between, every number. You just pick the right x value, you'll get any number you want. Interval of increase is going to be the same as y equal positive x cubed, because all it is shifted down 1. So we're going back to really the first one I did, the positive x cubed. He's going up from -2 to -1, x equal -1. In that section he's going up. Okay, the whole thing is increasing. Interval of decrease, this time I'm not going to have any. See, it's very extreme. These odd functions are extreme. Alright, the x-intercept, let's see, where does it cross the x-axis? There at +1. What's the y-intercept? They're at negative 1. What's the right end behavior? What's the right end doing? Is sweeping up. It's really, that's all you have to look at. Is it sweeping up or is it sweeping down? Sweeping up, positive ending. What's the left end behavior? As you go left, it's going to sweep down. Okay, the last one I want to do on cubic, because we can do a lot of problems, but they're all basically done the same. Any type of function is done the same. It's just fine what the parent function looks like and shift it around. Very important that you know what the function at least looks like. Doesn't hurt to take the time to do a little graph. You wouldn't necessarily have to have set up a grid like I do. Like you see, you can just do one. Just to draw an x-axis and a y-axis and just kind of do the general shape. Alright, so always comparing to the parent function, y equal x to the third. Okay, so x to the third, point, 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 and point. Alright, now the minus 1 is grouped in with the x, and in future functions, when we do square roots, that minus 1 is grouped in there with the x. Absolute value, that minus 1 is grouped in there with the x. 1 over x minus 1. That minus 1 is grouped with the x. The fraction, the root, the absolute value symbols, the parentheses, those are all grouping symbols. The minus 1 is right there with x. That means I'll shift left or right. Now it's kind of